So let's look at CH3, CH2, CH2, Br. All right, now, how many signals do you expect to see for this? So if you said 3, then you're correct. 3 signals. So let's take a closer look at this thing and put it all together. So you have a carbon, 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 bromo. So take a second, jot all that stuff down, and then let's put our H atoms all in there. So go ahead and put those in there. And then let's just label these things as, position A, position B, and position C. And remember, it's proton NMR that we're talking about. So when we talk about HA, it's really looking at these guys, right? HB would be the middle, and HC would be the H's that are next to the bromo group. All right, now let's take a look at A here down together. So just look at section A down here. So let's break this thing down into 3 sections. So let's look at A. So let's rewrite that structure down. So take a second, write that down. Put all of our H's in. Okay. So here's the way that you should be thinking of this. When we look at A, we're looking at these protons. So those protons are all chemically equivalent to each other. So put a little box around them, okay? So these are basically in a house. So think of them as being in a house, right? So there's your house, there's your roof. I know it's silly, but here's your chimney, right? It's a cold day, so smoke's coming out. Right, here's your sidewalk, so on and so forth. Front door, right? Anyway, that's your house. Now, your house has neighbors. You are in a house and you have neighbors. Sometimes you have them on the left-hand side and sometimes you have them on the right-hand side, right? But you have neighbors. In this case, you're at the end of the street. There's no neighbors on the left-hand side. So in this case, your neighbors are right here. So these are, right, your neighbors. How many people live in that house next to you? Well, there's 2. Right? There's this hydrogen, and then there's that guy, right? There's 2. So in this, you have 2 H's, which means that your N is equal to 2 here. Right? So if your N is equal to 2, then N plus 1 is equal to 3. So the peaks from this carbon connected to those 3 H's, it's really the 3 H's, but the peak caused by the H's that are in that house are going to look like a triplet. And the peak pattern should be a 1 to 2 to 1 ratio. And again, that's determined by Pascal's triangle. Now we're going to do the same thing for B. So then let's just draw another little line here. And let's look at B. So take a second, draw out that structure again. So you have your H, C, C, Br. Got all your H's there. Okay, so take a second, catch up with that. Pause it if you need to. All right, so now we're looking here at B. So we just, by default, said that B happens to be in the middle. So here you have a skinny house. Okay, so like a house in London or something. And then we look at this and we count up our neighbors. Well, let's look at our neighbors. So this side has 3 H's, and this side has 2 H's. Right? So in a perfect world, then you add these neighbors up. So 3 plus 2 equals 5 neighbors. Right? So that means N is equal to 5. So then n plus 1 equal to 6. So you'd expect to see a sextet there. So a sextet is going to look like this. 1, 2, something along those lines. It's, don't get a ruler out and check it against pascals, but there's 6 peaks there. That's the whole idea of that. And then we'll do the same thing for the next peak. So draw a little line here. Let's take a look at C. Now, if you're kind of getting an idea of this, then that's great. And we'll do some more examples here too as we end our little discussion. So take a second, bear with me, draw out these H's again. Now we called C this position. So it's another tall, skinny house, right? So take a second, catch up to drawing that and putting that together. So we look to our left, n is equal to 2 here. So n plus 1 is equal to 3. We expect to see a triplet here, right? 1 to 2 to 1 ratio for that triplet. All right, so we expect, if we look back at what we've done there, we know we're going to get 3 sets of peaks on the NMR. Those sets of peaks are going to be split into these patterns that we see for A, B, and C. Now, let's talk about upfield and downfield. So as far as what's upfield and downfield, this atom is electronegative. So it de-shields HC more than it does HB and more than it does HA because its proximity is closer to that of the H's at position C, B, and A, right? In descending order there. So when we put our spectrum together, let's draw a little line right here, and let's take a look at the proton NMR spectrum. So when we do that, we're going to have a straight line across right here, and let's zoom in a little bit here. Okay, and remember that we have a couple parts of this. So if you recall, right around 0, right, that's our tetramethylsilane. There could be other solvents that are used, but sometimes you'll see a peak there, and this is your chemical shift. Now, what's most deshielded are the protons that are closest, right, to that bromo group. So that happens to be the protons at C. So, right, that's these guys down here. So that should be a triplet. So we're going to move this thing over here for us. So we're going to put a triplet in here. 1, 2, 3. So there's a triplet. All right, and then those are, again, that's at position C. So then B is farther away, right? Right here. So being farther away, you're going to have a sextet over here. So 1, 2, 4. Right, because you're farther away, you're less deshielded. You're more shielded. Remember, this side of the spectrum more shielded, this side more deshielded. And then A comes next. So then this is at B, and this is at A. And we said at A, that's going to be a triplet. So putting it all together, that's what your spectrum is going to look like. Now, here's what you're going to typically be given. You're not usually given a formula and asked to draw the structure, although you can. So typically what you're going to be doing is you're going to be given this, right? And you're going to be asked to draw the structure. You can't draw it right now. You got to know what the molecular formula is. So it would be given to you as C3H7Br. Okay. Now there's another piece of information that we're going to talk about that's going to be given to you on the next page. So n plus 1, let's just make a note, and we'll come back to this thing in just a second. So n plus 1 tells us what we're next to, tells us what our neighbors are. But is there some piece of information that can tell us how many H's belong to us? Well, there is. So there's something called integration. So let's take a look at integration here. So integration, and we'll get into the theory in just a minute, but integration is the area under the curve, and it turns out that the area under the curve is proportional to the number of H's that give rise to that signal. So if we zoom out a little bit here and look at this, at carbon C, right, or at position C, I should say, there's 2 H's. So sometimes on the NMR spectra, you'll see the number 2 written there. Okay. At position B, you have 2 H's also, right? That's position B right here. There's your C. And at position A, you have 3. Okay. So together, I want to kind of put this in our notes right now. This number is what we call integration. It tells us what belongs to us. In other words, here's another way of thinking it. It's what's inside of our house. So what's inside of our house is here. Okay? And this peak pattern right here, this tells us basically what we're next to. Okay? So then let's look at this example and see how we might put this thing together. So forget about all the other stuff we saw on the other side, and let's see if we can construct this in kind of a meaningful way. Okay, so here's how I would go about doing this. For this first set of peaks over here at position C, the number 2 means that I am a CH2. So that's in my house. That's my integration to CH2. What I'm next to is something that gives rise to a triplet. So I'm next to a carbon atom, or we'll see, it could be other things sometimes, but it's typically going to be carbon for us at this point in time. I need to make my N plus 1 equal to 3. So then N is equal to 2, right? If you just solve for that, right? So because we're going backwards, right? So then what I need there is 2 H's here. Okay, so we're going to do this for every little peak here. So we move over here next to this next one. So we know that that guy also is a CH2. So there's our house. We know that because 2 is the integration. Now we count up the peaks. N plus 1 is equal to 6, so N is equal to 5 here. Now, you can't be next to a CH5. Now, probably what this means is that you're going to be next to a CH3, right, and a CH2. 2 plus 3 is 5. 5 plus 1 gives you 6, and that's where you see that splitting pattern. I'll do the same thing for A. Now, A in our home is a CH3. All right, again, it's because of that integration. It's a triplet, so we know that we're next to a CH2. And then, in essence, what we're going to do then is, by the way, it doesn't mean these are connected to each other, right? They're overlapping on top of each other. So it's like you have these pieces, and imagine if you could cut them out and put them on top of a light table. Certain parts are going to overlap with each other. So here's one way of doing this, and a lot of times students just like to kind of put it together and it makes sense to them. So if that works out and you can do it, that's fine, but here's another way. So let's take a look first at that middle section, CH2, CH2, CH3. Okay, so that was our home for that signal, right? So we can put a little thing there, okay? Well, what else do we have? Here over on this left-hand side, we have a CH2, CH2. Well, so here's a CH2 and a CH2. Right? And that signal from C is from this, right? and you can see where I'm going down here. Now we have a CH3, CH2. So that is a CH2, CH3, and that CH3 is what's giving rise to that signal, right? Now, in the end, we're still connected to a bromo, so probably going to put a bromo over here, right? And here, this is connected to that CH2. So basically, we're just really kind of adding these things up. So our full structure then would be, right, our bromo group to a CH2, right, because those add up to just being a CH2. And these guys add up to being another CH2, so connected to another CH2. And then those two folks down there at the end add up to being our CH3. And that is your structure. So we're going to practice that. We're going to talk about integration a little bit, and we're going to do some practice problems in our next lecture.